Good afternoon, everyone. In this class, we are about to learn concept learning. I hope I am clearly audible to you all. Just look at the definition for concept learning. In terms of your machine learning, the concept learning is basically a problem searching. That means searching the solution for the problem. Okay, that means problem of searching through a predefined space of potential hypothesis for the hypothesis that best fits the training examples. Okay, so that means here you can see the terminologies like hypothesis, potential hypothesis, and simply it is here it is given as hypothesis as like that. So the meaning here is your potential hypothesis means suitable solutions. Okay, so for a given problem statement, we are supposed to identify the suitable solutions, that is potential hypothesis for the hypothesis which fits very best to the given problem statement. Okay, so here we have taken the training examples. So for those training examples, we are trying to find the solutions. Okay, so from this image, you are able to see that we are beginning from the problem, then we are searching we are approaching various solutions, and we fix a solution which is very best for the given problem. Okay, there we stopping. Okay, so see here we are starting, and from here we are exploring various different solutions, right? So you are able to see this, I think, 1 minute. So here we are seeing, we are starting from this particular point. Okay, from this point we are moving here and there. That means we are searching various solutions. We are identifying various solutions, and finally we are fixing a solution which is best fit for the current problem. Okay, so this is what the concept learning, basics of the concept learning. Okay, so here the best fits is an important key terminology you are supposed to remember. Okay, so the concept learning is basically identifying the potential hypothesis. That is also a very important. We are supposed to identify a potential hypothesis. That means potential hypothesis means suitable solutions, best fit solutions, suitable solutions. Okay, so we have to identify suitable solutions for the given problem. Okay. So here also we have another definition. A task of searching potential hypothesis that best fits the given training example is the basic or a simple definition of the concept learning. Okay, so a task of searching potential hypothesis that best fits the given training examples is the best explanation or the definition for concept learning. Okay, so let us discuss this concept learning with a simple example. So we have 4 different examples, like given here as example 1, example 2, example 3, as well as up to 4. We have totally 4 examples, and we have 6 attributes. Okay, so this is attribute 1, attribute 2, and attribute 3, attribute 4, attribute 5, and attribute 6. So this is the decision part. Okay, based on these 6 attributes, we have to take a decision as like enjoy sport, either as yes or no. It is a binary result. It may be, if you are saying yes means, then it can be considered as 1. If you are saying no means, it can be considered as 0. Okay, so we are taking a decision based on the value of these 6 attributes. So these 6 attributes are the input spaces. Then this is an output space where we will be taking a decision as yes or no. So for example, some person X is willing to enjoy sports based on the climatic condition. So if the climatic condition is represented with 6 attributes. One is sky and air temperature, humidity, wind, water, as well as forecast. Okay, so sky involves here it is given as sky. Maybe sometimes it is sunny, sometimes it is rainy, and we may have in some other examples we may have sky condition as cloudy. Okay, so there are three different condition of the for the attribute sky. One is sunny, another one is rainy, another one is cloudy. Similarly, for air temperature, we are having two different types of condition. One is warm, another one is cold. Then humidity is normal, another one is high. Okay, then wind, it may be a strong wind or heavy wind, or it may be a lighter. So here all the four examples have the strong wind only. Then similarly, water, it is very warm, or sometimes if it is too rainy, obviously the water condition would be cold. Okay. Then similarly, forecasting, the future forecast would be prediction, whether the rain will come, whether the rain will come by 3 o'clock, whether the rain will come by 6 o'clock. As like that, we can have some predictions too. So this prediction says that same in the sense all the given attributes are the same. Here also same. Here there may be a chances for getting some changes. So these are the ways. These are the 6 attributes. In this example, we are going to take a decision. The machine, we are making the machine to take a decision based on the attributes, based on the input attributes. So this is what the basic idea of concept learning with a simple example. Okay, then look at this little more explanation about that concept learning. Okay, so basically our human learning, our learning involves acquiring general concepts from past experience. Yes, obviously we will be acquiring the general concept from our past experience. This is a very important key terminology we are supposed to remember related to human learning. Okay, so from past experience, we are learning from the past experience. For example, so we are supposed to identify different types of vehicle among all the vehicles based on some set of specific features. Okay, so there are say lot of vehicles over here. So among these vehicles, if you want to identify the car, then we may have some set of features for car. Right. So, in terms of its appearance, in terms of its color, in terms of its features, so we can differentiate cars from other vehicles, right? So, likewise, we are learning how we are able to differentiate it. We are able to differentiate the car from other vehicles with our knowledge gained from previous experiences. Okay. So, this is what the idea behind this. So, this set of features that differentiate cars can be called as the concept. So those features which are helpful for differentiating car from the other components are termed as the concept. That is what the concept. Concepts are basically the features. Okay, specific features which are helpful to differentiate car from other what's that vehicle. But for example, if you want to compare car with the bicycle, means in what way we can easily compare? In terms of number of wheels, right? So number of wheels for the car would be obviously 4. If it is for cycle, then if it is cycle, then it is 2. Okay, similarly seaters. So in car we may have, car may be of 5 seaters, but cycle may be a maybe we can have a 2-seaters as like that. And similarly other conditions like gearing system. So in terms of our car, we have the gears, but in terms of bicycle we don't have gears. Likewise, so we are able to bicycle, if it is bicycle means it is 0. So we are able to differentiate those vehicles with some set of specific features. We call those features as concepts. Okay, I hope all of you are able to understand the concept, meaning of the concept. What is the role of past experience in acquiring general concepts as like that? So in this way, the human learning is happening. Okay, then similarly, the machines also can learn from the concepts. So how it is possible? How the machine can learn from the concepts? That is what the coin term of this concepts learning. Okay, so machines can also learn from the concepts. Machine also can learn from the concepts in order to identify whether an object belongs to specific category or not. So we can, the machine can identify, for example, if you are having orange, if you are taking orange, the machine can identify whether orange is a category of fruit or it is category of vegetable, right? So how it can identify whether it is fruit as like that? It can identify based on its past experience. That is how it is gaining experience, by doing some training, right? So we are giving some set of training to the machine so that it is gaining some knowledge about the objects. So when it is tested, then obviously it recollect the knowledge it gained during the training phase, and then it will give you the respective result. Okay. So in order to find the hypothesis, in order to find the potential hypothesis, the machine should be trained properly, and the answers which delivered by the machine should exactly fit the problem statement. Okay. So that here we are using a terminology called best fits. Okay, so this is the way machine gets trained, and previously we have seen an example for how the human beings are getting trained for identifying an objects, right? Okay, so introducing general functions from the specific training example is a main issue of machine learning. Yes, we are introducing general function. This is very, very important concept you are supposed to remember, so that you will be getting clear picture about some algorithms like find-s algorithm, as well as the candidate elimination algorithms. Okay, those algorithms we will be discussing in our upcoming classes. So the main issues here is general functions. We are using general functions from specific training examples. Okay, then concept learning basically acquires the definition of general category from given sample. That sample may be either positive as well as negative. Okay, so that means a training example can be either positive or negative. From that examples, from those examples, the machine acquires the concept. Okay, so this particular concept learning theory is mainly applied in training the computers. Okay, so this is an outline of the concept learning. So we have seen basic definition for the concept learning. In what way the concept learning comes in our day-to-day life activities, how the concepts are supportable for taking decision. Here we have taken an example of enjoying sports based on the climatic condition. So based on these 6 attributes value, the decision is being taken. So as we have seen in our previous slide, we have both positive examples as well as negative examples. So positive examples are having the positive decisions. Negative examples are giving you the negative decisions. So in this table, you are able to see there are 3 positive decisions or 3 positive examples and 1 negative examples. Okay, so depends on the attributes. This decision can be taken. Okay, so let us come to this example once again. So here we have 4 different examples with 6 attributes. So in these 6 attributes, yes, 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 all 3 yes are the positive examples. Okay, so all these 3 are the positive example. This no indicates it is the negative example. Okay, so we are about to write the hypothesis. Okay, it is hypothesis be a vector of 6 constraints. Yes, obviously it should consider all these 6 constraints. 1 is sky, second one is air temperature, third one is humidity, fourth one is wind, and fifth one is water, and sixth one is the forecast. So based on these 6 parameters, the hypothesis need to be developed. Okay, specifying the values of those 6 attributes as given here. So let us take the sample hypothesis which is suitable for the given example to give you the positive result. We try to make it as positive. So let us take the first hypothesis. This is hypothesis 1. We have taken the first hypothesis. We can develop our own hypothesis, depends upon the attributes. So here I am taking sunny. So this is exactly matched with the sunny. Similarly, second attribute is warm. This also matched with warm. Third one is normal. This also matched with normal. Then fourth one is strong, and this also matched with the strong. Then the warm, again it is matching with the warm. Then same, this also matched with the same. So all these 6 attributes are exactly matching with the first example. Okay, so that it obviously it is a positive example. We are taking the decision as a positive one. Okay, so then we are moving to 1 minute. Later join பண்ண முடியும். ரெக்கார்டிங் வேற போயிட்டு இருக்கேன். So these are the positive examples, and rest of the let us check the second hypothesis. Okay, so in this second hypothesis, we are having rainy. We are having the attributes as like 1 minute. So in this second hypothesis, we are having the attributes like what? Rainy, warm, high, strong, warm, as well as same. Okay, so let us try to map with this. So first one is sunny. Okay, second one is so here second example, it is beginning with sunny. Okay, but here this particular hypothesis begins with rainy. So both are not matching. Similarly, the third attribute is warm, and here it is the third attribute is second attribute is warm. Here also the second attribute is warm. Then the third attribute is high. Here also it is high. Then the fourth attribute is strong, and the fourth attribute is strong. And similarly, fifth attribute, that is warm, and here it is warm. But then finally the last attribute is same. Here also we are having the same, but it is not this particular second hypothesis. What we have written is not suitable for the first attributes of the first 2 examples. Okay, here it is sunny, but here it is rainy. It is not matching. Okay, so obviously this particular hypothesis may not give you the proper solution. But if we have taken the first hypothesis and comparing with the second example, so sunny, it is matching. Warm, it is matching. Here it is normal, but here it is high. So first hypothesis is suitable for first example, but the first hypothesis is not suitable for the second example. Similarly, the first hypothesis is not suitable for the third example also. Here it is rainy, but here it is sunny. But even though it is not suitable, it is not matching with the third example, but this hypothesis is okay for this third example because it is a negative example. It is not a positive example. It is a negative example. If it is negative example, if it is able to admit some mismatches too. We are able to admit some mismatches, so that it is obviously give you the negative values. Okay, negative example. So that this first is suitable for the example 1. It is suitable. Then example 3 also it is suitable. This first one, and similarly this first hypothesis we are checking with the fourth example, sunny, warm, it is matching. See here, sunny and sunny matching, warm and warm is getting matching. Normal, here it is high, it is not get matched, but so it is mismatched. Similarly, strong getting matched, warm and cold it is not getting matched. Here we are getting some mismatches. Here also it is mismatches. So if it is mismatches, then obviously the result should be no, but here it is given as, so that this particular hypothesis is not suitable for example 4. It is not suitable for example 4. So it is suitable only for 1, 3. So likewise, we have written the next hypothesis, and we are comparing this particular hypothesis with all the What's that? All the example 1 we have to compare with example 2 we have to compare, and example 3 we have to compare. Similarly with example 4 also we have to compare. Okay, so we are able to find that there are some negative results. Sometimes instead of positive results, the hypothesis is going to give you the negative results. Similarly, the third hypothesis also written here. So it is also to be compared with the all the 4 examples. Then we found that this is also not suitable, this is also not suitable. None of these 3 hypotheses matching with the 4 examples. So that likewise you have to do the you have to generate the hypothesis with all these 6 attributes. Okay, so so here we are having 6 attributes, so that 6 power 6 with the 4 examples we are having. So you will be getting this much of combinations of hypothesis. You will be getting this much of combination of hypothesis. So handling this much huge hypothesis is very difficult. Okay, so we have to identify the suitable hypothesis by exploring these hypotheses one by one. So here, for your good understanding, I have given you the hypothesis, correct hypothesis which is suitable for all 4 examples. Okay, so let us take this hypothesis. For example, here we have taken the suitable hypothesis as like that we have taken is sunny. Okay, 1 minute. One is sunny, then another attribute is warm, then the third attribute is question mark, and the fourth attribute is strong. Okay, and the fifth one is question mark, comma, question mark, as like that we are having. Okay, so let us compare this particular hypothesis. This you consider this is hypothesis 1. So compare this particular hypothesis with example 1. Okay, example 1. So what is this example 1? Example 1 consists of it is a positive example. It consists of attributes like sunny and warm. Okay, sunny, warm, then normal, and another one is strong. Then the next one is what? Warm, W. And in short way I am writing warm, and final one is same. Okay, ma'am. See, now we are comparing this attribute, this example with this attribute. So how we are able to compare? Then what is this question mark? Okay, so we are having 2 different specification. One is question mark, another one is phi. Okay, so question mark, this is the pi, it is a null set which will not marked with, which cannot be matched with any attributes. But question mark, it is a general one, it can be matched with any attributes. Okay, suppose if there are any mismatches, then you can use the question mark to fill that gap. Okay, to fill that gap, which indicates that this particular hypothesis gets suitable for the rest of the attributes. Okay, 1 minute. See, here you are able to see that. See here, the attribute sunny in this hypothesis is getting mapped with the what's that? Example 1, right? So both are same attributes. 1 minute. So here it is sunny, and here in this example also sunny. So both of these attributes are getting matched. The next one is warm. Here warm and warm getting matched. Then third attribute is water. In this example we have the attribute as normal, but we have to write a hypothesis which is suitable for all the examples, so that since there is a chances for getting mismatch, here that particular attribute is replaced. If if there is any mismatch, then it can be replaced by the question mark. Okay. The next one is strong. Here we have strong, and this example also strong. Then the fifth attribute is warm, but fifth attribute is warm, and as well as the sixth attribute is same. Okay, so here in this first example, if you have taken warm and same, then it is getting mapped. But if you are moving to further examples, there is some changes, so that the common or general hypothesis which is suitable for all the example have this question mark for these two attributes. Why we have question mark? It is a general hypothesis where we need to map that particular hypothesis with all the other examples, all the suitable for all the examples, so that for the if you are having warm and same, it will be suitable only for the first two examples, but for the rest of the other two examples are getting different. Okay, so that we have to use the question mark here. So this is the hypothesis: sunny, warm, question mark, strong, question mark is suitable for, which is the suitable hypothesis, best fit hypothesis for the given examples. Okay, so let us check with this negative result. So let us check with that third example, which is having the negative result. So here it is sunny and here it is rainy. Obviously it is an opposite value, so that what it indicates that there is no match, then obviously it is a negative result. So that in the example also it is a negative result. Okay, then likewise you can compare this with the fourth example also: sunny and sunny, warm, it is warm. Then here it is high, but here it is question mark. This is also can be mapped. Suppose if there is any mismatch, we can replace that mismatch place attribute with question mark. Then strong, it is strong, getting mapped, and cool, here it is cool, so that it is also getting matched. Okay, then change, here it is there is a mismatch, so that it is both attributes are replaced by this question mark. If there is any mismatch, we can replace it with question mark. Okay, this is the suitable hypothesis for the given example. So how we are identifying this? So why we are moving to little advanced algorithm means, for 6 attributes, you imagine that you are identifying solution. We are generating combinations, different combinations like sunny, warm, normal, strong, warm, same. So there are 6 attributes. For 6 factorial of combinations we can generate, right? So similarly, for 4 examples, it should be multiplied by 4. So you will be getting a big value of combination. So checking all these combination one by one is a tedious task. So that we are moving some set of little advanced technique like finders algorithm as well as candidate elimination algorithm. So before getting into those algorithms, so here I have mentioned, right, the finders algorithm and the candidate elimination algorithm are the little advanced technique which will help you to overcome the difficulties in your normal hypothesis generation process. Okay, so that the first we will be studying about finders, then in the next class we will be learning about the candidate elimination algorithm. Okay. Look at this example, little brief. Let us have the instances as well as the target concepts, right? So for all the examples, we have one target. So we are trying to reach the target based on the nature of the attributes. So sky, air temperature, humidity, wind, water, and forecast. So all these 6 attributes helps you to take a decision about whether the person is enjoying the sport or he is not enjoying, right? So the enjoy sport gets value 1 when when the decision enjoy sports decision is yes. That means how we are able to arrive at this yes result based on these 6 attributes. Similarly, the enjoy sport also can be getting value as no based on the negative value with the hypothesis. Okay, so here you are having two important terminology to remember. One is instances, another one is target concept. Instances are denoted by X and the target concepts are denoted by C, and training examples are commonly denoted as D. Okay, see, task here is to learn a category description. That means concept. What do you mean by category description? It means concept. Learn a concept from a set of positive and negative training examples. This is the important task over here. What is the task we are about to do? Learning a category description. That means concept from set of positive and set of negative example. Set of positive and set of negative examples. Okay, so learning a concept. So concept may be an event or it may be an object, whatever it may be. So what experience we are gaining here? A set of training instances. So we will be getting a set of training instances over here, where X is the instance and C of X is the target concept. X is the instance and C of X is the target concept. Okay, target concept. Okay, then set of instances. What is set of instances? The set of items over which the concept is defined and denoted by X. So this is what the set of instances. Then target concept. What do you mean by target concept? The concept or function to be learned. The function to be learned or the concept to be learned are termed as the target concept. Okay, ma'am. So it is those target concepts are denoted by C. Target concepts are denoted by C. So it can be seen as a Boolean valued function defined over X. X is an instance and can be represented as target concept is represented as S tends to a set of 0, 1. 0 indicates the negative result and 1 indicates the positive result. So 1 means it is yes, 0 indicates it is no. Okay, so that is what the target concept. The target concept we are able to see in this table itself. We are having two different target concept. That is the binary value. One is 0, another one is 1. 0 indicates no, and 1 means it is an yes. Okay, this is the way we are learning this. The concept learning is performed. Then let us look into the concept of hypothesis representation. How we are supposed to represent the hypothesis. Okay, so here the hypothesis can be represented or denoted by a letter called H. Okay, how we can represent the hypothesis? The hypothesis can be represented by a letter called H. Okay, so it represents all possible hypotheses that the learner may consider regarding the identity of the target concept. Yes, obviously, H involves all the hypotheses, all possible hypotheses. So in our previous slide, we have written 3 to 4 hypotheses, right? So likewise, this capital H involves, or it is a collection of various hypotheses. Okay, so each hypothesis H in capital H represents a Boolean valued function. Yes, obviously, you have a Boolean valued function because we have only zeros and ones. That means 0 indicates the negative result and 1 indicates the positive result. Yes, right. So yes is denoted by 1 and no is denoted by 0. Then in concept learning, the goal of the learner is to find hypothesis H. We have to find hypothesis H such that the hypothesis H should be equal to the concept of that instances. So what is that CFX? So we have seen that CFX is the target concept, right? So the concept what we are writing, so the concept, the hypothesis what we are writing should be same as that of your target concept. That means what the hypothesis what we are developing should be very much supportable for the target. Okay, then simple representation basically done with the conjunction of constraints on the instance attributes. Yes, we are doing that with the conjunction of constraints. We are combining 2 or more constraints. Then next, each hypothesis will be a vector of 6 constraints. Yes, obviously we have totally 6 attributes, right? So if there are 6 attributes, all those 6 attributes will behave differently, right? So that we are having 6 constraints specifying the value of these 6 attributes. So what are those 6 attributes? So 6 attributes are sky, air temperature, humidity, wind, water, as well as the forecast. So these are the 6 attributes. Then instances. So instances are denoted by X. So some instances satisfies all the constraints of the hypothesis H. Then H classifies X as a positive example. Yes, we have seen this. No. So what is positive example? The hypothesis what you have written is matched with all the attributes of one particular example, then that particular example is denoted as a positive example. Otherwise, it is a negative example. Then we have seen the question mark over there, right? So what is this question mark? Question mark indicates, it indicates any value which is acceptable for the attribute. It will not care about the specificity of the attribute. So it is able to accept, it indicates that any value which is acceptable for the attribute. Okay, so question mark is basically, please remember, it is most general hypothesis. Question mark indicates that it is most general hypothesis which is suitable for maximum possible instances. Okay, so most general hypothesis is denoted by the question mark. Okay, then similarly we can have the combination of single value too. Then we have another important attribute, attribute which is pi, which indicates that no value. Okay, that means what? No value is acceptable for the attribute. Okay, so question mark means any value. Question mark means any value can be acceptable for as an attribute. Pi means no value is acceptable for attribute. That means it will not, it is not a general one, a generic one. It is most specific hypothesis. Okay, so I hope all of you are now able to understand what is the difference between question mark and pi. So question mark indicates it is the general hypothesis. Question mark means G, general hypothesis. Pi means it is a specific hypothesis. Okay, it is most specific hypothesis. That means it will not accept anything. No attribute is considered as a correct attribute. Okay, it is denoted with this pi. So this hypothesis, in this hypothesis representation, you learned about H. H means a set of hypotheses. Then each hypothesis are the Boolean valued function. Yes, obviously there are positive examples and negative examples. When the developed hypothesis is most suitable to all the attributes of one particular example, then obviously you will be getting a positive result. So it is positive example. Otherwise, it gives you the negative result. So it is a negative example. Okay. Then apart from that, you have to remember two important attributes. One is question mark. Another one is pi. Question mark indicates it is most general hypothesis. Pi indicates it is most specific hypothesis. Okay. So most general means it is ready to accept all type of attributes. Most specific means it will not accept none of the attributes. Okay. So these are the important concepts you are supposed to remember during related with your hypothesis representation. Okay. Then we can discuss further in the next class. Okay. So just a quick recap. In this class, we studied about concept learning. You all have a good idea about what is concept learning, and we have studied with this image. You are able to get a clear picture of concept learning. There are so many solutions. There may be so many solutions, but we have to identify the solution which is the best suitable, best fits for the given problem statement. We have taken an example where the attributes plays a vital role in taking decision of enjoying sport. Then we have seen positive example, what is negative example, and how the learning happens for human, how the learning is happening for the machine, how it is getting, how the machine is getting this concept learning idea, how it is getting trained. We have studied. Okay, and we have with this example how the hypothesis were generated, how it is getting mapped with the example also we have seen. And a very important thing is about two important algorithms in order to overcome the difficulties in this huge amount of or huge combination of the attributes, huge trial. We are able to overcome that with the help of two algorithms, find this and the candidate elimination algorithm. Then we have seen the task over here and how it is represented, how the set of instances can be represented, how the experience is gained from the set of instances. All these things we have discussed. Then apart from that, the hypothesis representation also we have discussed clearly. So in the next class, as a continuation of this this example, we will be getting in sufficiently large set of training examples, but go through that large set of examples and getting trial based solution is very difficult and may not be accurate. So we are moving to little advanced concept. So we can rest of the thing we can discuss in the next class.